Hello, everyone. May I have your attention, please? Let's start the first keynote speech for our ICC 2025. Again, I'm Wen Zhonggao. Here I want to introduce my friend, long-term friend, Tihao Chiang, to be the first keynote speaker. Tihao Chiang received a doctorate degree from Columbia University in 1995. Afterward, he worked at the David Sarnoff Research Center as a program manager for 4 years. He then returned to Taiwan to become a professor in National Jiao Tong University. 10 years later, he joined Ambarella, where he currently serves the general chair of Ambarella Taiwan Limited. Dr. Chiang is an IEEE Fellow and holds many USA and international patents. He has also published more than 100 technical papers and conference papers in the field of video and signal processing. I know him in around 24 or 25. I still remember in 2024, I worked in company before that. Then I joined university, and he decided quit from university in 24 to 28, right? So 2004, yeah. So anyway, he made the right decision. So his company run very, very well. Please join me to welcome Professor Tihao Chiang.
Thank you, Professor Gao. Coming back is like coming home. I used to come to ICCE back in actually probably starting in the early 90s, and also I appreciate my opportunity at that time. David Sarnoff Research Center gave me a job and helped me to advance my career and point me a lot of directions for future research. Now let me get to the today's talk. Today's talk, I'm going to talk about AI processors and for a few applications, and in particular, generative AI, autonomous driving, and automotive applications. Let me see. Page down. Okay, and I'll do a self-introduction of the company I work for. Ambarella has 9 offices around the world and was started at 2004. And I was the founding team in the Taiwan office to start the office. And right now the office has about 450 people. Globally, we have close to 1,000 people worldwide, headquartered in Santa Clara. And we went IPO back in 2012. Right now, we've been a public company for 13 years. And the company has survived for 20 years. And here's our headquarters. And here's a brief award we received as a company, and just for your information. But later I'll come back to it because of the automotive business we are involved in. It requires a lot of certificate. So I will go there in a minute. Okay, so this is since 2012, AlexNet appears in the world, has changed the world afterwards. It has been 13 years afterwards. And AI has been a key research topic. And our company, or we think that in terms of actually deployment of the AI or computer vision, in terms of business, of course, there's always new innovations, but as a company to survive, we need to pay our employees, we need to have revenues. So we have to explain to our investors what kind of revenues can be generated from the AI business. So the first market we identify is a security camera. For security camera, it used to be just recording the video, and later you have to, if you want to use it, then you have to search for it. And searching a video security camera can be very painful. So security camera is an obvious applications for AI. And the volume also is big enough, over 100 million per year. So that's an obvious market. So that's one first market we identify. And the second market we think that's going to happen will be the smart home. Smart home is a market that security camera can happen in two places. One is office, the place you work, and the second place is your home. So accidentally, accordingly, then the next obvious market is automobile, because you either stay at home or you go to office, and in between you ride in your cars. So if you cover your daily life, then smart home is the next obvious market to address. And home security is very important. And there are also many applications for home security. And the third market, like I said, the automotive market. When you go from home to office, or during your off time, you want to go to the restaurants and you want to visit some place, then you need to find out where to go and which restaurant you want to go, which location you want to go. And a lot of decisions are made on the car. So that's the third market we identify for AI to flourish. And this is the time frame we are thinking of. Right now, so far, although we want it to be as soon as possible, however, the automotive industry so far has advanced mostly to the level 2+. So most of the, I will give you examples, cameras on the cars. And of course, Tesla is the leading company that provides more than L2+. We are glad they are leading the way. So that's close to L2+ or L3. But ultimately, we want to do level 4, autonomous driving. That's what everyone agrees the future will be. Many companies have agreed this direction. And for security camera, we think in the beginning we only have a simple security camera that can record and put it onto a big server. And later we find out that we need to search for certain scene or certain object. Then AI comes in to be very handy. Still, it's the person, human itself, looking for those objects. So that's the second stage of IP security camera. It's almost like autonomous driving. Persons still do the driving, persons still do the security camera application search or identify the object, but with some assistance from AI. Ultimately, we hope everything is automatic. So that's the future. And so let me address the first market and explain the steps to achieve or to serve that market. If you want to do automobile market, there are a lot of things that you need to take care. So the question is, why is automotive market so hard? There are several aspects. As a company, doing consumer electronics is actually easier. Easier in a sense that you get your investment back faster. So if you do, for example, an IP security camera, or you do a sports camera, then you start a project, and within a year or two, you see your revenue coming back. So your speed of a return on your investment is very fast. However, for automotive, just use our company as an example. It took us so far 8 years of investment already, and each year over $100 million of investment in terms of resources, tape out, human resource, engineering, and tools, and et cetera. So that's a big investment, and we only see partial return. Mostly on L2 plus, L3 and L4 are still incoming. So to be in the automotive business, you need to have 3 important things. The OEM will look at you and check you if you have the 3 most important things: functional safety, cybersecurity, and whether your software is reliable. Automotive business concerns about human lives, so you have to have functional safety by design at the beginning. So there's a certificate or standard, ISO 26262. They will dig into your system and see if your functional safety is certified. So this takes at least 2 to 3 years of a certification process. Then you don't want your car to be hacked by a hacker, remote control your car. So you want to maintain your cybersecurity. There's also a standard for that. It's 21434. And then that's also another certificate that you need to pass. Again, that's another 2 to 3 year process. All these processes will be executed simultaneously. So that will cost the company sometimes 2 to 3 times of human resource investment, just for example. Then your software has to be reliable. It cannot hang. It cannot have exceptions. It has to be running all the time. When it fails, it needs to inform the central processor that it has failed. For example, if your electronic rear mirror is broken, you need to set it into the regular mirror mode, and you need to notify the system, like your car, if the gas is about to run out, you need to inform the owner that gas is almost running out. But that's a red light. That's a yellow light. That's not red light. But if your brake is broken, then you have a red light. So ASPICE is for your software. And then to classify the safety, we have the industry has assigned the different levels of safety levels, what we refer to as ASIL. So you are required to do hazard analysis and risk assessment, and then you have to come up with the solutions. And for ASIL levels, there are 4 levels: A, B, C, and D. So for different products, you have to comply with different levels of ASIL at the chip level. So to do an ASIL chip, it's way more expensive than a regular commercial chip. And for example, if you want to do dash cam, you have to comply with the ASIL B. And if you want to do autonomous driving, definitely you need to comply with the ASIL D. And each product needs to be certified by by a third party automotive auditor to certify it. So it's a lot of a process, and so that's why if you, like I said, a consumer electronic project takes 2 years to 3 years to see your return on investment. For automotive, if you start from a POC, proof of concept, first you have to start from a proof of concept, then later you need to do the real product. Takes 5 years for completion. Then your company needs to be managed well. Your company governance needs to be up to their standard. So you need to have quality, and for component, you need to pass the MAQ, MSR. If you are tier 1, then you have to pass IATF 16949, which is even more strict. And of course, the customer's information is in your hand, so you need to make sure these informations are secure. So you have to make sure that your company do not get hacked. So you have to pass ISO 2001. And as an automotive supplier, you need to make sure that you have you can provide this component for more than 8 years, because typically life cycle is at least 8 years, and for cars, sometimes it can run 10 plus years. So your company needs to promise that first, your company will be around, and secondly, you won't get you will continue to ship your component even there is some natural disaster or some other issues. So make sure, because for a car, one component missing means the whole assembly line will stop. That will cost the OEM huge amount of money, and of course there will be as a component supplier, there will be penalty associated with it if you fail to produce those components, whether it's your problem or natural disaster or your supplier's problem. It's on the component. Of course, tier 1 also have to absorb certain risks. So when it comes to automotive, everything is about the risk. So for automotive applications, there are 2 types. One is level 2 plus. So this ASIL-B, and that's what our company has been doing for the past 8 years for our bread and butter. So let me just show you some examples. For example, fleet management. This is everyday life. Most of the truck companies in US probably has a certain form of fleet management. And surround view, a lot of new cars have installed that. And e-mirror, so electronic mirror, rear view mirror. So these and in cabinet driver DMS, driver monitor system, to make sure the driver does not fall asleep, give warning sign, warning signal, or if it's a fleet management, they will notify the employer that this truck driver is sleeping or should take a rest. All kinds of warning. So to provide warning, ASIL-B is sufficient. And if you want the car to control brake or the steering wheel, you have to be more than ASIL-B, so C or D. So these have less requirement on the safety, so it's shipping every day. And the next level is more complicated automotive application, which is the domain controller. Domain controller is like a central processor unit in PC. So it's in the automotive business, there are 2 main processors on the system. One is for infotainment, so the processor control your communications as well as your entertainment system. That's what we call infotainment center. And then there's another processor which controls your brake, steering wheel, and how you drive, how you plan your path, and all these safety-related issue. So this is what they call a domain controller. So these kind of applications require the chip to compile with SOD, and it has low power, low latency, so that you cannot send the automotive decision up to cloud. It's too slow. 10 milliseconds, you have to have a response. And the applications is, of course, autonomous driving. Also, autonomous driving can be done with cameras, like Tesla use a camera to do its autonomous driving. Also, a lot of companies have started to use currently mostly 3D radar, and so nowadays becomes 4D radar, has the vertical angle, the height can be identified, horizontal, depth, and speed. That's 3D, and then if you have vertical, you have 4D, and Ambarella has 4D radar technology. So then as a domain controller, you should fuse these information into your decision making, because you have different modes of information, EM wave and the camera, and can be LiDAR, can be radar. We are not a sensor specific, we are neutral, and our chip can, this chip can supply all of them. Okay, so let me give you our solution, which is the CV3. Let me show you a video. This video will be a little bit longer, but give you the idea with a video.
To create a safe and robust Level 2+ to Level 4 autonomous driving system, you need a purpose-built and power-efficient central domain controller that perceives your vehicle's surroundings by fusing data from multiple sensors and then plans a seamless driving path. That's precisely what you get with Ambarella's new CV3, a central domain controller that perceives the vehicle's surroundings using a single CV3 SoC to simultaneously process a combination of sensors, including long-range cameras to sense objects farther away from the vehicle, wide-angle cameras to sense objects and pedestrians near the vehicle, and radar, sonar, LiDAR, and other redundant sensors, while enabling future optimizations of the sensor mix. A single CV3 can intelligently fuse the data from all of those sensors simultaneously while providing the highest levels of AI processing. Once the vehicle's surroundings are perceived, the CV3 helps it estimate all likely paths for any nearby agents, such as pedestrians and other vehicles. Based on these estimates and sensor data about the AV's surroundings, the CV3 then plans the driving path. The CV3 also processes in-cabin RGB IR cameras that monitor drivers for distraction and fatigue in semi-autonomous vehicles, as well as during automated driving to confirm they are able to take control if needed. Ambarella's scalable CV3 portfolio has multiple options to meet the product strategies of OEMs and Tier 1s alike, from our entry-level CV3s for multi-camera ADAS to our premium CV3 SoCs for Level 4 fully automated driving. The CV3 family leverages Ambarella's extensive experience in image processing, AI computing, computer vision processing, video capture, adaptive AI radar algorithms, functional safety, and cybersecurity, with the headroom for future over-the-air software updates. Together, these SoCs offer high performance, lower power, and low latency for ADAS and automated driving applications. The CV3 SoC family has up to 500 ETOPS of CVflow AI engine processing for neural networks, as well as separate general vector processors for other algorithm types, including radar data processing and classic computer vision algorithms. Advanced image signal processing addresses challenging lighting, weather, and driving conditions. The on-chip ARM CPUs are divided into multiple processing clusters for ASIL B applications, as well as a safety island for ASIL D applications. The CV3 family also supports numerous camera inputs, as well as radar, sonar, and LiDAR, connected via CAN, Ethernet, and MIPI CSI, along with H.265 encoding of all cameras for recording data. The integrated GPU enables surround view rendering, while the dense stereo and optical flow engines provide depth and motion perception. Ambarella's unified software ecosystem provides software drivers, tools, and an SDK for easy integration, neural network optimization, and application development. With the new CV3 Central Domain Controller family, Ambarella is enabling you to create power-efficient, robust, and safe autonomous vehicles up to level 4.
So this is CV3, our domain controller. We have a lineup of various AI processing power to address different costs. And like I said, we started back in 2018. In fact, when we acquired the autonomous driving group in Italy, that was back in 2015. So if you count that, it's 9 years of continuous investment, continuous demonstration of autonomous driving. And this is a different application. I just show you the demo. Next, I'll move on to, since I have a limit time, I want to cover many applications. Next one is the AIoT. So AIoT address the security camera and the various different smaller device at the edge. We are not a cloud AI chip supplier. We are the edge AI supplier. And edge AI supplier has different requirement. So there's an opportunity for small companies like us. So again, for lower tops applications, IP security camera. Your security camera used to be dumb security camera. Now it's a smart security camera. So you want to add AI processing power, and you want it to be low power. So you have to have you can have a longer battery life. You want it to respond as quickly as possible, low latency, and probably you prefer not to upload to the cloud. So then you want privacy, and you don't want your security camera to break down because Wi-Fi is down. So you want 24 hours, 7 days reliability, and you want security, meaning that your data is safe at home instead of going to the cloud. Also, if you use a cloud for your IP smart security camera, you probably have to pay for the storage cost and subscription cost, as well as when you upload your image or video for the cloud to process. That will cost you money too. These are recurring costs. So home application, smart security camera. This direction right now is actually becoming more obvious. I think last year, 2004, the top three vendors all have various versions of video search and analytics using AI, but most of them are using cloud-based solution. And we think there's an opportunity for edge and local AI computation. Let me give you an example. First, I will explain the tool we use. Our company is not developing neural network models. We are just supporting the customer to choose their own neural net models. But in this case, I'll use CLIP. And CLIP is an open AI model, zero-shot pre-training. And it can be done with less than 1 TOPS. So very low power edge security camera can run CLIP with very low power. And the model size also very small, half a billion parameter. Let me start the video. Can we see the video? The video is not. I'm playing back video, but doesn't show on the screen. Oh, okay. Let me just
close the slideshow, exit the slides.
Oh, okay. Exit slideshow. Okay, let me do that. Close the. Let me just kill the whole presentation.
Now, yeah, you can just minimize it.
Okay. There you go. All right. So this is a video of our company as a sample. So has 25 minutes of a video. So if you want to search for it, so then you this is the content as a. Then you can start to search for various objects. And this the model is CLIP, so OpenAI. It's Ambarella. It's not Ambarella network. We just show that this kind of application. So you start to search for red car, it goes there, and your blue car, it goes there. Okay, so various and on the edge camera, you are able to do that. Okay, let me stop. So, but at least you get the idea. Let me see. Okay, so I just show you the CLIP demo. So if there's another type of I only have 6 more minutes, but I think I can make it. Okay, so for higher performance AI box, what we call, you can have a local AI server. So the benefit is that you can do a security camera video search server to retrofit your existing infrastructure, since you have invested so much in the current infrastructure with all the security camera. So there are 2 ways to do this. One way is if you use an AI-enabled edge security camera, then it can extract all the metadata or the vectors back to the AI server, and then locally, not to the cloud. Then you are able to do search like I just did with the CLIP. And Or if your infrastructure doesn't have an AI-enabled camera, then you can send a video stream back to the AI server. It can real-time decode it, and then while recording it, it will register all these metadata at the high frame rate, and then find the stuff you want to search. So this is obviously very good for airport, train station, and street, and also for home security if you have multiple cameras at home. So, okay, so this time I killed, this time I hope I will do better. So in this case, we have 16, and a further optimized version, we can have 25 2 megapixel strings simultaneously decoding, and then perform clip-based search. So the model can be your own proprietary models, and we support both CNN-based as well as transformer-based models. Then you can search, for example, if you look for black car, you immediately see certain channels will show up. So it's very easy to search the video, and without human intervention. Also, if your edge camera has AI in capability, then you can send out an instruction saying that, oh, I want to search a man in black suit, and then it will identify that object and send it to you, advanced warning, real time. Okay, so that's the idea. So I'm almost down to the last one. Okay. So last one is the most popular subject. After that, after this, I think I'm done. I'm 3 minutes away. So it's the most hot or popular topic, VLM, Vision Language Model. So our chip can support VLM, and this high-performance VLM model can do over 50 TOPS, as high as 500 TOPS. So the special feature it has is PCIe enabled. So with that interface, you are able to do a PCIe card and plug it onto regular existing infrastructure server. In fact, we make the form factor compatible with the existing computer server. The server company gave us the instruction, and actually, in fact, help us to build their boards. And they are one of the most leading server company in the industry. So it's all compatible. You just plug in, and if you want, each server can support typical is 8 cards. So you can have a server farm basically, and VLM can do a lot of things. Just imagine the application that if your autonomous driving can have VLM. A lot of people have thought about that already. For example, a lot of autonomous driving vehicle becomes a dumb vehicle when there's an accident and the police shows up, and it couldn't understand that there's an accident incoming, and you should follow the guy in the police suit for any instruction. So VLM comes in very handy when you do autonomous driving. And this VLM server gives you ChatGPT enabled function within the firewall. So let me just show you the demo, and then I will be done. Okay. All right. I think I'm okay. Yes, yes, yes. So this demo is just to show you this PCIe card. So it enables, of course, this model is Lava. This version, the demo we show here is a 13 billion parameters, but our system can go up to 34B. So large language model is supported on our chip. So some companies, they are concerned about their employees using ChatGPT on the internet. So this provides a solution that you can do ChatGPT within the firewall. Also allows you to do various task-specific, domain-specific models for your own company. So you have both of the best of both worlds. You have ChatGPT, you also have VLM, and because it analyzes image as well as high-resolution video, and it's private, and furthermore, low cost, low latency, no subscription fee, low bandwidth, just private your own VLM server. And usually the challenge is to support such a big model. Remember, the clip is less than 1B model, and for these Lava model is like a 34B. And then if you ask me if we can do 100, we're working on that. So far, it's very challenging just to do up to 34B. But I think sometimes people call it a small language model. So I think I'm done with my presentation today. We still have 3 minutes for Q&A. Okay, thank you very much.
So if anybody has a quick question, just raise your hand. Have a question here?
Okay. Thanks for your excellent talk. My question is for the AI chip, for your AI chip system. Usually it needs a high bandwidth memory requirement. How do you solve this problem in your system? Thank you.
I'm glad that you asked actually exactly the right question. Our system can be very low cost because we use standard PC memory, LPDDR4, LPDDR5, and those are very low bandwidth memory. And the reason why we can do that is because our company's philosophy is algorithm first. We optimize our algorithm to support both the CNN as well as the transformer, so it can use not high bandwidth memory, so that it can be low cost. Thank you very much. Yes.
Okay, Brian with CTA. Can your models, like your VLM, can they be updated in the field, or are they fixed?
That's correct. It can be OTA, yes. Actually, our customer requires us to do OTA. Almost sports camera, security camera, automotive camera, they all require over-the-air update. Has to happen. Very secure. Security also very important. Cannot be hacked. I still have one and a half minutes. So.
Well, I guess I'll stick one question in here since I have the microphone. When you update, do you have to go through the certification process all over again, or do you have some fallback procedures or rollback where you can automatically do that without having to go through the?
Very good question. So that's a question our customer asks us. So if it's a minor update, then the auditor has to approve. You have to write a lot of documents to justify it's a minor modifications. But if it's a redesign of the whole system, you have to go back to the drawing board and do the HERA analysis, the risk analysis. That's 2-year process. So doing a chip for automotive is very expensive.
Well,
thank you.
Thank you, Dr. Chiang. We're going to set up for the next keynote. Thank you so much.
All right. Thank you.
Professor Todi?